digital twin platform is actually an advanced digital representation that mirrors a physical object or a system or a process actually in real time.
It typically works like based on Excel and WhatsApp. But how do you expect that the teams working in the industry to migrate or use this high-tech digital twin model?
I mean, all the sectors, definitely digital twin has a major role to play. 347 tons of carbon emissions have been done away with. So this is how
fantastic.
The technology is helping the city of Ayodhya. Using a digital twin, engineers can simulate the entire construction process under various conditions to ensure that two halves of the arch they meet precisely at the top. Okay.
Yeah, so when you said safety, also, I just recollected a recent incident that recently happened, the construction of a 4.5 kilometer long Silkyara tunnel in Uttarakhand. So,
yes.
So the misery is 40 plus workers were trapped for more than 2 weeks due to collapse of under construction part of a tunnel. So can digital twin help the monitoring or design teams of such project with an early warning or to change the design of support system, considering continuously changing geology throughout the alignment of tunnel during the progress of the work?
Certainly, yes, of course. This incident that you described now, which is the Silkyara tunnel collapse, is a stark reminder of the risks associated with the underground construction, particularly in the geologically complex areas such as mountain regions of Uttarakhand. Okay?
Yes.
Digital twin technology, of course, has the potential to significantly enhance the safety and the efficiency of such projects, okay, by providing advanced monitoring capabilities and some kind of predictive analytics which can actually help people in taking decisions. So what are the areas where we can actually look at the consumption of utilization of digital twin? Okay, one is, of course, your advanced geological and structural monitoring, the real-time data integration, right? Yes. By embedding some kind of sensors through the tunnel in the construction area, the real-time data on geological movements, the stress points, and the material behavior can be continuously kind of collected. This data can be integrated into the digital twin platform to monitor the tunnel's structural integrity. Okay, that's one area. Other one is the geological prediction. Okay, digital twins can use machine learning algorithms to analyze data from geological surveys and ongoing excavation activities. This analysis can predict geological shifts or instability that might actually not be visible or anticipated by the traditional methods. Oh. The other area which I can actually look at area of where digital twin can be used here is the simulation and scenario planning. Okay, you want to look at some kind of construction simulations, right? Before I want to go into the construction, I want to look at certain scenarios. Before I look at saying that I want to understand the risk involved or the complexity involved in this construction. How do I simulate those things? Again, digital twin can actually help you there. Risk assessments. Okay, digital twin allows for scenario planning. Okay, that's one of the major advantages of having digital twins, where the engineers can actually simulate potential failures and assess the impact of various contingencies. This enables the design team to develop more robust mitigation strategies before the issues arise. Okay, and then even when I look at the design adaptation and in case I want to do some kind of optimization basis certain analysis, I can actually do that. The dynamic design adjustments can happen as construction progresses. I see that, hey, I have started this way, but looks like there is some problem actually, right? And I want to look at some new geological data. It becomes available after a period of time, which might change my entire, simulation process, etc. I can still use it to make, use the digital twin to kind of, come up with some kind of better alternatives, etc., right? Changes in the support system, such as reinforcement types, and then the spacing and the materials also can be modeled here. Then how do you actually look at some kind of early warning systems? Digital twin actually can help you do that. Some kind of predictive alerts saying that, hey, this is what is happening there, now how do you think that this will span out in the next 1 day or 24 hours or maybe 48 hours? So that is another area where we can look at. In remote areas, right, we really need a robust communication, right? The collaboration and communication is kind of very, very important when you are in these kind of places, How does a centralized information hub gets integrated again to a digital twin platform? Because I need to actually communicate and collaborate, sourcing various data from people, etc. Even when it comes to the final part of handover, when you do even the documentation and compliance, right? All these things can be captured onto digital twin so that the person who's taking over, because what happens is in most of the projects, right? There are different phases of the infrastructure project lifecycle, and different organizations do different kinds of jobs. Somebody will be doing the planning work, somebody will be doing the design work, somebody is actually doing the analysis, somebody else is doing. But all these things, the one common thread between all these people is data. Okay. And
Right.
digital twin can actually host that to ensure that everybody is looking at the single source of truth. Okay.
So,
So I think use of digital twin technology can span across any sector or any kind of industries, and of course in different phases of life cycle. I think this is just an example that we took, and maybe if there are digital twins which can also become a part and parcel of every project. Okay, now there is a think tank which has been formed by the Ministry of Road Transport and Highways on digital twin,
oh,
which is looking at, hey, how does this become a part and parcel of every project actually, right? And then the Ministry of Housing and Urban Affairs, for the water supply network, they are actually talking about using digital twin, right? Similarly, there are digital twin technology which is being recommended for various other infrastructure projects as well. And globally, there are many projects which are getting executed on the digital twin platform, which is really, really helping the entire chain of people in this entire project beneficial. Yeah.
okay. So the existing various tools are some developments integrate them together and used in digital twin to reap in more benefits. That's what you're trying to say.
Absolutely. Absolutely. Yeah.
Also, by adopting digital twin, because we are working slowly, we are working in silos. So the planning department, design department, construction department, whatnot, like the supply chain. So if everything is together, for the management, top level management, it's easy for them to visualize the entire picture of the project. I think that's really very nice.
Absolutely, absolutely. See, the one of the major challenges today is that everybody is working in silos today, and the right hand doesn't know what the left hand is doing. Or when there is a handover of data or handover of process which happens, there are a lot of eyebrows raised. I think the common platform of digital twin actually can help most of the organizations overcome this problem. Yeah.
Good. Scada, the supervisory control and data acquisition systems are extensively used where projects are geographically widespread. Scada is used in water management, power grids, oil and gas, renewable energy, traffic management, railway systems, airport operations. So Scada is used primarily in real-time monitoring and control of entire physical infrastructure. So functionality-wise, how digital twin is different from Scada? And do we need
Okay.
to integrate both of these tools, or digital twin can replace Scada? Please
Okay. Great. Great.
insight
Yeah.
into.
Yeah, great question actually, because SCADA has been used for quite a long time now, especially in the utility sector. So when
Exactly.
it comes to SCADA systems and digital twins, I would say that uh, both are crucial technologies in the realm of the industrial operations and infrastructure management, but they serve distinct and they are complementary functions. Okay. Now let's look at how it is actually used in different kinds of industries. So understanding of how each of them operate can clarify whether they should be integrated or if one could potentially replace the another. So let's take an example of SCADA system. They are designed to actually gather data from sensors and other input devices, of course, which is spread across a wide geographical area. Okay, primarily for the purposes of, say, monitoring and controlling the physical processes.
Correct.
So let's look at why SCADA, where are SCADA used? Like one is the real-time data collection. Okay, they are very good in collecting real-time data. If you look at the electricity board, they use SCADA data. Water supply network people, they use SCADA data for real-time stuff. They're also used for control, right? They allow the operators to control physically the processes remotely, adjusting settings and other stuff, and responding to the system alerts as and when it is necessary. Alerts and alarms, that's another area. SCADA systems are configured to provide alerts based on some of the predefined criteria that you actually define to ensure the immediate attention to any kind of critical challenges or failures. And another interesting stuff about Scada is the historical data tracking, right? While more primitive than digital twins in this regard, Scada systems do track historical operational data, which can be used for trending and operational planning. Okay, so in case you want to do say time-based forecast kind of stuff and all, the past data is going to be available. Scada data is going to be very, very useful for you. When it comes to digital twin, as I said, digital twin is actually a virtual model of a physical system or a process or a product. It integrates real-time data, historical data, machine learning, and the simulation capabilities to not only monitor, but also predict the behavior of its physical counterpart. Now, here is how the digital twin can extend beyond the capabilities of Scada. One, the simulation modeling, right? Unlike Scada, digital twins can simulate future scenarios and actually can model the potential outcomes, which helps in predictive maintenance and operational planning. It also helps you in predictive analytics. They utilize advanced analytics and, of course, the artificial intelligence to predict faults and optimize performance, which can preemptively address the issues before they get escalated, right? Another area where I see digital twin, kind of scoring over Scada is the integration of the diverse kind of data sources. Now we talked about multiple data sources getting integrated, right? Digital twins also can, integrate data as IoT devices, your ERP systems, the external environments, database systems, and your CMMS modules, etc., all those stuff. And it gives you a very, very holistic view of the system. Okay. Now let's look at the question of, hey, should I integrate or replace? Okay.
Correct.
Of course, there are complementary roles out here, right? Rather than replacing Scada, digital twins can be integrated to enhance them. Okay. Scada systems provide the real-time monitoring and the control infrastructure that feeds into the digital twin. The digital twin in turn uses this data with other inputs to provide deeper insights and predictive analytics. So it is Scada plus plus. Okay.
Okay.
How does it enhance the capability? Right. By integrating the digital twin, a Scada system data can be used not just for monitoring and controlling, but also for optimizing the operations through the simulation and predictions. This integration allows operational adjustment to be more data-driven and strategically planned.
Okay.
We also look at how do you future-proof the infrastructure, okay, with the help of this integration. With the combination of Scada and the digital twin can future-proof the infrastructure by ensuring that the operations not only respond to the current conditions, but also adapt to the predictable future scenarios as well as the changes. Okay. Now, in most of the cases, right, digital twins do not replace Scada systems. Rather, they enhance the value of the data collected by Scada. Integrating the Scada systems with digital twin is a very, very powerful combination that leverages real-time control with advanced predictive analytical capabilities. Thereby, it enables more efficient, reliable, and sophisticated management of your complex systems. This synergy actually can lead to significantly improved decision-making and operational efficiencies across various industries where both the systems are applicable.
Oh, so it's a complementing thing, use of
Absolutely.
Scada. So it can exploit.
It is not or, it is and.
Yeah.
I said it is not or, it is and. Yeah.
Okay. So it exploits the real-time monitoring of Scada capabilities, and with the help of AML, that is artificial intelligence and machine learning, the simulation capabilities, the predictive analysis, and many more things can be done by using digital twin. That's good.
Absolutely. Yeah.
So you have explained already how the digital twin is helpful in design optimization. But I want to understand one more thing, whether digital twin is helpful in avoiding reworks during construction.
No, absolutely. There is a lot of advantage.
Because reworks is a very huge cost and time-consuming aspect in all the infrastructure industry sectors.
Yeah, that's right. So definitely, digital twin technology it impacts the construction industry by significantly reducing the need for reworks. Okay, one of the major source of additional cost and project delay is this rework. Right, rework in construction it typically occurs due to inaccuracies because of say initial planning. You might have gone wrong, miscommunication among the stakeholders. Right. and then you look at some site, you assume something in the site, there are unexpected site conditions which might emerge, right? Digital twins actually address these issues by providing a high fidelity, real-time and connected model of the construction process. So let's look at some of the ways in which you can actually use digital twin in construction to avoid rework. One is basically the enhanced planning and visualization. We call it maybe the virtual prototyping, right? Before the physical work begins, you actually use digital twins, which allows you to create and testing of creation and testing of various virtual prototypes of the construction project. Okay, this will help you in identifying the potential design and construction issues that might require rework if discovered during the physical construction phase. Okay, the other area which I can look at is the 3D visualization. Okay, advanced visualization tools, including the AR, the VR. These things enable the project teams to visualize the construction process and their final outcome. This actually can also help the stakeholders catch the design flaws or any kind of conflicts that might be arising before they are built, by reducing the need for any kind of changes at a later stage. Okay. Real-time monitoring and adjustment. We talked about some kind of sensor data integration, which can actually help you in managing this situation much better. Then I talked about the communication and collaboration. Okay, then we were looking at the predictive analytics and the simulation process, the quality control, compliance, and of course the precision and accuracy. All these things put together will be able to give you a fantastic output and reduce your rework during construction if the digital twin is actually proper to put in place. So in summary, of course, I can say that when you are integrating digital twin into the construction projects, the companies can not only reduce the frequency and the scope of reworks, but also enhance the overall project efficiency and the quality. The ability to actually visualize, simulate, and adjust in the virtual environment before and during the physical construction processes represents a significant shift towards more proactive and informed management of construction projects. This technological approach actually leads to better outcomes. And of course, there's going to be a substantial cost saving over the life cycle of the entire building or the infrastructure project, actually. Yeah.
So this 3D visual model that will be available because of with the help of digital twin in the beginning of the project, that is after the design or during the design, and also during construction at different stages, we can visualize what's been done and what is to be done together in a 3D visual model, because of which
exactly
any anomalies are there, we can find it out and fix it then and there, instead of it's already done and then do the rework.
Yeah, so it is, it is always good to start early in a digital twin journey. That's what I would advise, actually. So it's available. The 3D model, when you start, say, for example, you have actually started the digital twin journey right from your design stage. Obviously, you are doing you're designing in a 3D environment. Of course, it can get integrated. At a later stage, also, you can actually, get this integrated. So 3D models can, it's a part and parcel of your data which can go into a digital twin plan. Yeah.
Okay, good. But you said like new projects, it's fine. We can plan it off to implement or use it from design phase itself. But if the projects are legacy projects which are already completed in operation stage, so how good is it to use digital twin to get the benefits out of that?
Okay, good question. In fact, a lot of customers of ours ask them, saying that, hey, I'm already in the construction phase, or I'm already in the operation maintenance phase. Can I now start with the digital twin? The answer is definitely yes. Okay, digital twin can be introduced in a project at any kind of stage. So if you look at the new projects, of course, digital twins are used from the design phase through the construction operation. They actually serve as dynamic tools, which is used for simulation or monitoring, or they help in design, decision making, etc. But when it actually comes to, say, projects which are already, in the construction phase or in the operation, yes, not an issue. We can actually, get the entire data set onto a digital twin platform. There are various methods through which you collect the data, and then you put it on a digital twin platform, and start utilizing, the advantages of the digital twin platform at that stage onwards. Okay. So, your maintenance and operations, right? Predictive maintenance and operations is going to be a handy stuff when you're on a digital twin platform. and operational efficiency can be brought in. When you're looking at asset monitoring, you can actually use digital twin to a larger extent, which will help you in kind of real-time monitoring, the health assessments. Even when you're looking at some kind of say upgrades and retrofitting, right? A lot of scenario testing can be done with the help of a digital twin platform before implementing physical changes, various upgrade scenarios, etc., can have. So what kind of impacts, it's going to actually make, if I bring in a digital twin, whether can it simulate how modifications would impact the existing systems? Will it help in planning, executing an upgrade that will minimize my disruptions, etc. And also, we talked about these handover stuff, right? The documentation and compliance. Again, it's going to be very, very helpful. Not just that, even in the training aspects also, digital twin can be very, very helpful for people for the operator training, because you have a lot of these virtual models which are actually created, right, that can be used for that. And of course, the safety aspect of it, by analyzing an operational data, digital twins can actually identify the safety risk, and it can propose certain enhancements to mitigate those risks. In conclusion, I can say that, whether it is new project or an existing asset or an existing project, digital twin definitely can offer significant advantage by bridging the gap between the physical operation and the digital capabilities. There are multiple projects today in India where the digital twin journey has started at a later stage, and we are actually seeing the progress being made. Yeah.
Okay. So it can be very well used in implementation stage or the operation stage. Yeah, good. As you said, if you use digital twin, achieve breakthroughs in areas like predictive maintenance, design optimization, avoid reworks, etc., that will reap cost savings to the projects. But how do you see the future of digital twins? Does it lead to a paradigm shift of industry towards digital twin, which works presently on traditional tools and mechanism?
So if you actually look at some of the latest developments which are happening, everybody is kind of moving away from legacy and looking towards the new technologies, right? People are talking about AI, they're talking about ML. Hey, how do I integrate? I mean, today even kids are talking about AI, ML. Okay, how do I actually simplify my work? So the point is that the application of a digital twin technology is definitely enhanced by this, AI, artificial intelligence, and the machine learning algorithm. Of course, it has got a major, I would say, a transformative potential for the infrastructure projects in India. Okay, now we talked about some of these. Use cases, right? The predictive maintenance, where we talked about digital twins, when it is integrated to a sensor and an IoT device, it is able to help you collect the data continuously and then monitor their condition and performance. The artificial intelligence and machine learning algorithms actually help analyze this data to predict the wear and tear. Okay, if I'm talking about a particular asset, it is really going to help me manage this. And what are those things? Definitely, if I want to reduce the downtime, yes, I can actually do that. Yeah, hey, do I want to look at extending my asset life cycle? Yes, that is also possible there. How do I reduce my maintenance costs? Yes, you will be able to do that. Not just that, of course, these technologies is also helping you do design optimization, and we discussed on that. It is also talking about the enhanced safety and reliability. We are looking at any kind of saving in terms of the construction costs, right? And then how do you actually streamline your construction processes so that there are not much of rework, etc. We talked about that. And it will also help you for precise resource allocation. Okay, if you're looking at some kind of real-time monitoring, or you want to look at the enhanced collaborations, or you look at any kind of change management, how does this actually help? Of course, there is a paradigm shift in terms of the way projects are managed in the Indian infrastructure. Okay, the shift to the digital twin technology represents a significant transformation in how infrastructure projects are planned and executed and maintained in India today. How can you actually make this happen? The question is like, how do we do it, right? One, of course, is the government support. Okay, the policies which will kind of encourage digital technology, use of digital technologies, the innovations, or any kind of subsidies or financial incentives for utilization of technologies for any of the contractors or the consultants. Also, you generate or bring in standards mandating the digital twin technology. For example, I give you examples of Ministry of Housing and Urban Affairs, and I talked about examples of Ministry of Road Transport and Highways, which is there. The second most important thing I think is that India is a big intellectual hub, right? I would say, the education institutes play a major role in kind of, giving us the best of the resources today for any kind of, project requirements. You develop skills for in terms of digital twins with these people. Of course, like for example, Bentley, Bentley Systems today has, under MOUs with some of the leading institutions where digital twin is actually taught in colleges today. Okay, in fact, there is a curriculum which gets integrated with different streams. Like for example, you take civil engineering. Of course, you do maybe first year with the basic stuff, and then by the by the time you graduate in the fourth year, you are well versed with the kind of concept and the tools which are related to this, right? The other area which I look at is, how do you collaborate with the tech companies? Okay, because mainstream and digital twin go hand in hand. Okay, because it's all about different kinds of data getting integrated. So how do you ensure that these people are made aware of this technology, how they can actually use? Because at the end of the day, it's a platform. You can integrate many stuff there. Okay, while there are various teams of actually rolling out this, I feel that it is again the mindset. Okay, people will always say that, hey, there may be challenges. So how do you? Yeah, of course, every project is not very easy. At the same time, every project is not tough. Okay,
Right.
We need to kind of start thinking smartly, use the tools, and ensure that we are able to actually overcome whatever problems, that statements that we are actually doing. I feel that digital twin is basically encompassing your artificial intelligence and ML, and it is a big, I would say, boon for the Indian infrastructure sector, or I would say the global infrastructure sector today, where everybody in the chain, whether it is the owner operator, the general consultant, or the project management consultant, or the contractor, or even somebody who's actually doing the operation maintenance, is kind of will benefit significantly using this technology. Yeah.
Okay. It's very good, Kannan. Thank you very much. With your talk, you have taken our audience to a virtual world within civil engineering. With real-time data from digital twin, the site engineer to CEO would be on the same page with respect to the status or development of the projects. So the application of digital twin appears to offer immense potential, the way you have told and explained a number of examples. I hope that the fruits of realization of this tool will lead to this extensive use in more and more projects in Indian infra industry. So thank you once again. Have a nice day, Kannan. Namaskar.
Thanks a lot, Viswanadh. Thanks for the opportunity. I think this session would definitely benefit your audience to understand more about digital twin. I would also encourage the viewers to visit www.bentley.com and go and click the link which talks about digital twin to learn more about the technology. Thank you so much, and have a great evening. Bye.
Okay. Thank you, audience, for listening our show. Stay connected to IndInfra Podcast with more and more interesting stories that enlighten your knowledge. Thank you. Bye-bye.